Welcome to today's webinar entitled What is AWS? So today's agenda really is to give you an overview of what AWS is and why people are using it, to take a 1,000-foot view on all the services in the toolbox, or as many as we can cover in the time that we have. It's a broad portfolio of services and products that we offer. And a look at the top two questions really that people have when approaching AWS, particularly from an enterprise perspective. So let's crack on with that. So a bit of background really. So clearly I'm from Amazon, and Amazon Web Services is part of the Amazon.com family of businesses. And there are three main parts to that family. One being the consumer business, where we've all probably got an account and we've ordered gifts maybe at Christmas time. There's a seller business in that retail e-commerce infrastructure that enables third parties to sell through the infrastructure. And that's really part of the story of where Amazon Web Services came from. Then, of course, there's the IT infrastructure side, the cloud computing business with hundreds of thousands of customers on that platform, Amazon Web Services. Now, I often get asked the question, how did Amazon retail get into cloud computing? If you like, how did they go from packing boxes in distribution centers to unpacking server boxes in data centers and racking them back on shelves? Well, the journey started for us over 10 years ago, and it's been in the making for that sort of time. 6 years ago, Amazon Web Services was born, but the journey to that point really started with the enablement of those sellers on Amazon Retail, because we started to slice the infrastructure that we were providing, supporting our e-commerce businesses up and offering it to third parties to use, for third parties to sell through. As part of that journey, we got quite smart on how we deployed applications on a scalable and global basis. And we moved from monolithic, if you like, exotic hardware and software to commodity, highly distributed systems and consistent deployments across the globe. And we also started some early sort of test forays into the developer community, because one of the very first web services that we deployed was actually a catalog search. So a simple web service API on top of the Amazon book catalog enabled third parties to search our book catalog and embed results in their own websites. And the uptake on that really took us by surprise. It went ballistic. So we took a step back and we said, what if we could wrap everything that we're doing now in terms of service orientation, in terms of provisioning of systems globally to support our e-commerce and our seller businesses. And we did the same thing for all of that wrapped as a web service. And that's really where AWS came from. It was that blinding flash of the obvious that we can do it for ourselves, therefore we can offer it to other people via a web service API. So 6 years ago now, AWS mission statement was set, and it's exactly the same now as it was then, and it's to enable businesses and developers to use web services to build scalable, sophisticated applications. And it's worth noting that web services, it says it in our name, but that's really what people are now calling the cloud, and the AWS cloud will use the terms interchangeably. One myth to bust, of course, being part of a retail organisation, I often get asked what happens at Christmas. Will people that have compute resources in your Elastic Compute Cloud get those resources taken back when Amazon needs extra capacity to process the Christmas orders? And that's absolutely not the case. Amazon Web Services is not excess capacity from the retail organisation. It was set up as a strategic part of the business. It's a business in its own right. Amazon Retail is a customer of that business. And testament to the strategic nature and the size of this business is that most popular internet businesses are powered by Amazon Web Services. So some logos there that I'm sure you'll recognize from Instagram, Pinterest, Etsy, and so on. But it's not just the latest internet startups or internet phenomenons that are on AWS. It's also trusted by enterprises. So again, out of those hundreds of thousands of customers, some well-known brands, and we probably touch Amazon Web Services in one shape or form often in our daily lives. So whether it be from streaming music in Spotify to at home using our Samsung smart TVs with the Smart Hub application behind them, or indeed looking at media on The Guardian and so on. We're using Amazon Web Services in some shape or form. So it's trusted by enterprises and startups alike. An interesting statistic on Amazon Web Services is that each day AWS adds the equivalent server capacity to power Amazon Retail when it was a $5 billion enterprise. Now that was back in 2003, and a 5.2 billion retail business. We had 7,800 employees, give or take, and we had a whole lot of servers behind the scenes running that infrastructure. Another statistic which is interesting, which is the objects in storage in our simple storage service S3. Simple storage service allows you to store anything from 1 byte to 5 terabytes in size. If you use Dropbox, you're using S3. If you use Spotify, you're streaming music from S3. And many different solutions back themselves onto S3. And we've just surpassed, the end of last year, 1.3 trillion objects in storage. And at the peak transaction rate, we're topping 835 transactions per second, reading and writing into and out of that platform. So it's a significant operation. It's at high scale. We understand how to operate systems at high availability. And that's a lot of objects to manage. So the success of it sort of breeds off its own sort of statistics. Another stat, which is a new stat that we're releasing, is that 3.7 million clusters, or EMR jobs, Elastic MapReduce. This is Hadoop, a way to parallelize the computational analysis of large data sets. We can see the curve growing, so more and more people are spinning up clusters of computers to analyze data sets that previously it was uneconomic or unachievable in a time frame to do so. So EMR jobs are on the curve growth as well. And innovation is really in our DNA. So we're always innovating on behalf of our customers, because the more we innovate, the more services we provide to you, the more you'll use and consume AWS. And in the first 11 months of 2012, we released 158 new features. Now those dots are days in the month where we released one or more features. So it's an ongoing activity for us. We're releasing new features all of the time. So what is this all about really? What is AWS at its heart? Well, the concept of utility computing is where it's all at. Now, if you think about a utility like electricity, when you use electricity, you expect it to be there when you plug into a socket. You expect it to turn on when you turn the switch, so it's on demand. You only expect to pay for what you use, and you expect it to be the same wherever you plug in across the grid. And if you think about computing or infrastructure inside a data center, what we're doing at Amazon Web Services is wrapping that data center in those same properties, making it on demand. You only pay for what you use. It's uniform wherever you use it within the global infrastructure, and it's highly available. It's always there when you need it, so you can trust and rely upon it. And the trick is that we wrapped all of that infrastructure, if you like, wrapped the data center in an API, so that you can access anything that goes on inside that data center, from standing up some compute to install some server software, for example, to installing and instantiating a database, to distributing content through a global distribution network, to manage storage, workflows, security, and so on. Pay-as-you-go, uniform and highly available nature all comes into play via that single consistent API. Now, just as you would plug into a grid to acquire a utility like electricity, the AWS network is a global one, and it sits on what we call fundamental regions around the world. So regions are places where you can choose to run your compute workloads, so to store data in something like S3, for example. And once you choose to run something in that region, it will never leave that region. So they're geographically isolated. So they're useful constructs for in terms of data jurisdiction. If you want to keep something within the EU, place it in the EU region. Within a region, we have the concept of availability zones. Availability zones are considered physically distinct data centers or collections of data centers, and there are 2 or more availability zones in a region. So you can build highly available applications by architecting across availability zones. And some of the services that I'll take you through later are fundamentally built across availability zones by nature, so they're already highly available, or multi-AZ as we call them. And then lastly, we have edge locations. So whether you're wanting to respond to DNS queries, or you want to push static content or stream video media to people around the globe, we have edge locations that enable you to serve those customers as fast as possible from the locations that they're at. So they're not always traversing a global network to get response from your applications or services. They can obviously get responses from edge locations too. Now all of this, as I said before, is available at the end of a web service call. And here are two simple command line commands that wrap a web service call, produce a SOAP command behind the scenes, that instantiates some servers in our EU region. We're instantiating 3 small servers and 5 medium servers, based upon different what we call machine images, which are freeze-dried copies or static copies of machines, installed software and so on, that when you start them, they come up being a particular flavour. Now those just as easily could be stood up in one of our US regions, and here I'm bringing some extra large instances up in the US East. So you can see at the simple call of a web service, I can programmatically access the resources in a data center. And of course I can also turn them off programmatically as well. And this is drastically different from the way you'd approach traditional data centers and co-location, where the lead cycle, the planning cycle, the capital investment and so on would inhibit being able to start a server and stop it within the hour. Now all of these web services calls wrap other services as well. So by way of example, I'm here authorizing a firewall port at the top left of my screen. I'm creating Elastic Load Balancer at the bottom left, and I'm defining an auto-scaling group where I can have a group of servers that will be a minimum of 2 servers in a region, but can grow in a pool up to 200 based upon some properties. But of course, all of those web services also get wrapped up into a console. So you can graphically drive the Amazon Web Services infrastructure via the AWS console too. Okay, so given that infrastructure and that global footprint, why are customers adopting cloud computing? Well, the first reason that they're adopting them is that it's a variable expense platform, that pay-as-you-go nature. So they can replace capital expenditure with a variable expense. Move things off from a complex approval process onto a monthly pay-as-you-go. So versus the physical installation they might have to go through on-premise, the acquisition, the raising of purchase orders, the stumping up of the cash in advance to acquire some physical hardware. With AWS, it costs you nothing to get started and you'll only pay for what you use. Another reason why customers are adopting cloud is economies of scale. Because we have so many customers on the platform, they can achieve a lower variable expense than if they were trying to implement some sort of cloud computing model within their own facilities. So beyond virtualization, part of being with a large set of customers enables us to innovate on behalf of all of you and for us to keep prices as low as possible across the board. So if you look at people like Samsung, Commonwealth Bank or Foursquare, Samsung with their Smart Hub application, which drives the latest smart TVs, save $34 million on using AWS in the first instance versus using some sort of virtualized infrastructure within their own facilities. And we often talk about a virtuous cycle. And if you think about how we can inject more AWS usage, we provide new features, new services, we develop an ecosystem that enables you to do more on the platform, and therefore we get more usage of the platform. That drives economies of scale and allows us to innovate at a very large scale around the technology that we provide, so that we can provide technologies at the lowest cost. And that enables us then to pass on those costs and price reductions to you. So over 2006, since we started off on this journey, 23 price reductions, and we're always trying to pass on those benefits back to you so that the cycle repeats. Another reason why customers are adopting cloud computing is this idea of elastic capacity, i.e. no need to guess capacity requirements and therefore over provision some sort of set of resources you have in a traditional data center. If you look at these curves where the blue line is what I predicted the workload on my application or service to be, and the orange line being the actual demand that hits me, there are 2 real portions that can be illustrated on this chart. Is at the bottom left, where I've got less demand than I've predicted, then I have waste. I've over-provisioned the physical resources. I've bought too much kit, I've spent too much time scaling out systems and so on. Versus when the actual demand catches us out and we don't have enough capacity, customer dissatisfaction results. We can't service our customers. We lose transactions and revenue. People go and find another website to browse to get their responses quicker. So elastic capacity is all about following the curve with the right amount of resources at the right point in time. Balanced resources, only paying for what you need to get the job done. And we'll illustrate that point through some of the services as I go into the toolbox today. Another reason is speed and agility. So you can get infrastructure in minutes, not weeks. And I've hinted at this before. So if you think about some of the customers and their deployment times, News Limited, who are in Australia, part of News Corporation, reducing application deployment times from 2 months to go from the start of a process to provisioned in live to 3 days. Because at the end of an API call, they can configure infrastructure. They don't have to wait for a ticket to be queued. They don't have to wait for hardware to be provisioned or for virtualized space to be made available. And again, the story repeats across our customer base, something which is unachievable with physical resources. So in an old world, infrastructure in weeks, and I'm sure we've all been in a queue, like the diagram on the left, where our ticket is stuck in a queue and we're waiting on constrained resources that are in a very expensive data center to become available, versus adding a new development environment at the click of a button, adding a new production environment, adding 1,000 servers, removing 1,000 servers, all at the click of a button that can be wrapped against those command calls against our APIs. Because of that speed and agility as well, you can experiment often and fail quickly at a low cost. So that fosters innovation versus having to justify acquiring resources to take a bit of a risk on a service or a product. And with Amazon, we find that the speed at which customers innovate and the speed at which products and services are released and then they're iterated upon and maybe pivoted upon is far increased versus what would happen traditionally where the resources are constrained and there's a drag placed upon that innovation cycle. Next up, people can focus on a business because they're no longer focusing on what we call undifferentiated heavy IT lifting, because we take care of things like data centers, power, cooling, cabling, and so on. So you don't have to. So you just need to really focus upon the business that you're delivering, not on the need to configure new software, build new data centers, install new hardware, and so on. So we take away the undifferentiated IT lifting. Another last point is that customers can access a global network and can go global in minutes and reach a global audience. And there are many examples in the customer base where this has happened. Small companies or small ideas within larger companies that have really taken off and they've needed to expand rapidly, and they've been able to do so over the AWS network by taking an application and deploying it across multiple regions and deploying content at edge locations to support demand that's coming at them. And we'll talk about some examples throughout these slides of people that have done just that. So I mentioned before this idea of elasticity, and I thought I'd really bring it home by showing you some statistics from one of our major customers, Amazon.com. Now this is a traffic chart that shows you a weekly traffic profile to visitors to the Amazon retail site. Obviously I don't have a vertical access, but you can get the idea. These are significant peaks and troughs, regular on a daily basis. And if I look at November traffic to Amazon.com, November just gone, we can see that at the end of the month we have a significant growth. So as people near the end of a month, the buying cycle increases on this retail organization. Now, traditionally, before Amazon Retail were using AWS, the provision capacity was about 15% over peak. So during the month of November and the build up to that end peak, they'd have to bring in new hardware, rack and stack it, bring it online, test it, and so on. And that was resulting in 76% wasted unused capacity. Okay, so stuff that was sat idle versus 24% utilization of those machines, the software, and the infrastructure. Now, two dates for Amazon Retail were significant. November the 10th, 2010, the Amazon.com infrastructure turned off the last physical web server. And in October 2011, the same thing happened in the European business. So since that transition onto AWS, the curve now looks like this. So real statistics, these are provisioned instances to handle particular workloads. So the blue line being just enough capacity, shrinking, growing throughout the days of the month to these peaks at the end of the month. And Amazon Retail only pay for what they use. When they're not consuming resources, they're turned off, they're not paying for them. Another example of elastic capacity in action is a company called Animoto. Animoto lets you upload an MP3 file and a range of photographs and it will do some clever things and mix the photos into a movie based upon the beats and the music, and give you a movie back that you can then download. Now, they had the bright idea that in 2008 where they would integrate with Facebook and allow you to log in via Facebook and access your social graph. Now, you could do the same thing, upload an MP3, but this time you looked at your Facebook photo albums. Do the same task, but all your friends that were tagged inside those photographs would be notified that they're in a movie. Would they like to come and see it? Come and have a go yourself. And based upon accessing that social graph, they scaled from 40 servers to 5,000 in 3 days. Now, they architected around AWS using some of the technologies that I'll show you today. And they've architected with best principles such that they were able to sit back and watch that growth happen automatically. Their servers elastically grew using a concept called auto-scaling. And when the peak of demand passed, the auto-scaling brought back the number of services supporting the application and the website, and they stopped paying for the resources. They only paid it just for what they needed to get the job done. Something which would be unachievable for 3 guys if they'd have to go and rack and stack physical kit. Okay, so that's a bit of background. So now let's have a bit of a deep dive on the services in the toolbox. So there are many services in the toolbox, and I'll try and give you some of the key ones and describe what they do, so at least you have a broad understanding of the capabilities of the tools in the portfolio. And I'll do that based upon a reference model, so a classic sort of enterprise stack wedding cake. So we'll start at the bottom and we'll end up at the top at deployment administration services. So I've already mentioned at the global infrastructure layer we have regions. So these are independent collection of AWS resources in a defined geography. So for example, if you want to use S3, you would choose a region for your bucket to be hosted. If you want to start an EC2 instance, a virtual machine, you choose a region for which you want to deploy it to. Okay, so these are geographically isolated and form a solid foundation for meeting some of your location-dependent privacy and compliance requirements. Within a region, we have availability zones, and these are, think about these as being distinct data centers, separate power, separate floodplains, and so on. So that if you deploy an EC2 server into a region and you deploy it across more than one availability zone, you have a high availability configuration, or you have the bedrock in order to build HA applications. And lastly, I'd mention these edge locations, servicing things like our global DNS service called Route 53 and CloudFront Content Delivery Network. So above those global infrastructure sort of foundation services, we then have some networking services which you should be aware of. Firstly, we enable you to connect directly between your data center and an AWS facility, and you can do that via different locations where you can, if you like, cross connect in those facilities, and you can effectively buy a 1 gig or a 10 gig port, dedicated bandwidth, private line into AWS. So if you're looking at AWS as something that you want to host privately facing services in versus maybe public internet services, Direct Connect gives you consistency around that connection. And over Direct Connect and indeed the internet, you can layer a VPN, so you can secure your tunnel into AWS. We provide the hardware endpoints that you effectively rent by the hour inside our facilities, and you have a hardware endpoint, maybe a Cisco router at your end. You download a configuration and you'll establish a VPN connection across the internet, or indeed against a Direct Connect connection. Once you've done these things, you can also take a slice of the AWS cloud. We have a concept called virtual private cloud that enables you to separate yourselves from general network traffic, extend your network address ranges into AWS, define subnets, routing tables, and so on, giving you a degree of extra control around the networking that goes on in AWS. Still on shared resources in terms of a public cloud offering, but you have separation all the way down to the network layer now, so you can define your own address ranges and be confident of that separation at that layer. Last in the networking space, slightly different from fundamental networking services, is Route 53. So we have a Route 53 global DNS service that has one really interesting property that you should take away with yourselves today, is that it gives a 100% request reply guarantee. So if you're providing an internet-facing service and your DNS provider doesn't direct your customers to your application servers, you may as well not have any application servers there. So if your DNS fails, that's a bad thing. You're not even getting customers to your front door. So having a DNS backbone that you can trust is sort of key to any internet-facing service, and Route 53 provides you with those SLAs and guarantees. Then we're moving up into like the fundamental building blocks of most applications built within the AWS cloud, and that is Elastic Compute Cloud, EC2. So this is where you can stand up a server of range in size from a very small, called a micro, from 2 cents an hour. You only pay for what you use. All of these servers have hourly rates. And you can go up to very large cluster computes. We can go up to instance sizes with 240 gigabytes of memory in an instance. Again, you're only paying the hourly rate for what you want to use. You can have Linux distributions, or you can have Windows distributions. So if you want to stand up a Windows 2013 server, the price of that license for that server is included in the hourly rate. So you get full root administrator access. This is your server to do what you wish with. And it's disposable. You can come and go on this. You can acquire them when you need them. You can throw them away when you're done. And one of the really interesting things around pricing models for these things is that you have an on-demand price. But if you have servers you're running 24/7, you can reserve them and ultimately pay less and have a really good ROI over 6 to 9 months. You can also access some of the maybe more exotic servers over a spot instance price. Maybe if you're running very large Hadoop jobs and you want to acquire some larger server types to consume and process very large sets of data, you can do that on the spot market. So essentially bidding on unused capacity, and we'll give you a much reduced price on the understanding that if the price goes above what you're bidding, then you'll lose that server. So some really interesting use cases for using spot. Reserved instances can save you loads of money, and on demand you can just obviously click and go right there and then. Wrapping EC2, and those examples I've given you, like of Amazon Retail or Animoto, they use something called auto-scaling. So auto-scaling is the framework within AWS that enables you to add more servers or take servers away based upon some sort of triggers. So it gives you control over the pool of resources to support some sort of workload. So it could be that this group here that I've shown you was a minimum of 4 and a maximum of 200. It could grow based upon the CPU load on average across all those servers. As it goes above a threshold, add some more servers. As it goes below a threshold, take them away. It could be latency as seen from your web users. It could be the depth of a queue of messages that you're needing to process on a batch job. As the queue grows, add more servers, and so on. It can also be done by schedule or manually. So you could have auto-scaling take effect on a Friday night at your peak of demand. You pre-warm, you add more servers, and on Saturday morning you take them away again on a defined schedule. So auto-scaling is the tool that enables you to grow and shrink the EC2 resources behind some sort of application. If you've got multiple application servers or web servers or whatever happens to be running on these EC2 instances, often you need to load balance requests across them. So traditionally you might install a software load balancer, or you might install a Cisco or an F5 piece of hardware. You might have to then deploy those in an HA fashion inside your data centers, and then you'd have to string them together maybe across data centers for failover. Elastic Load Balancer is our virtualized equivalent of those things. So it's an Elastic Load Balancer service, operates at a regional level and can load balance across instances sat in multiple availability zones in a region, and it automatically takes instances in and out of service depending upon whether it works out if they're unhealthy or healthy. And the common use case is doing SSL offload as well. You can choose your ciphers, upload your keys into the load balancer, and then you can offload that load from your backend servers as well. Then we move from compute to storage. So S3 is a fundamental bedrock of many different applications out there. So compute on EC2, data often in S3. And S3 is an object storage platform. So think of it as a very, very large, scalable, elastic web server for serving objects of any type, from 1 byte to 5 terabytes in size. As I said before, if you're using Dropbox, your files are stored in S3. If you're streaming music from Spotify, your music files are streaming out of S3. Now the unique thing about S3 is that we store copies of data multiple times across multiple physical facilities to achieve what we call 11 nines durability of objects. So the system is designed to support 11 nines of durability. So in reality what that means is that once data is in S3, it's kept. and any problems with any copies of that data are automatically repaired, and your data is safe and secure. So you can store anything in here, whether it be backups, logs, static content for websites, and it goes beyond simple object storage. It versions objects. You can put lifecycle policies around it to push data into something called Glacier, which I'll talk about later as well. So as I said before, S3 Spotify is one of the most common and well-known examples of hosting data. Think about the volume of media that's there, the number of requests made against that service, and S3 is a fundamental backbone of Spotify. So when Emil, the operations director at Spotify, was looking for a service, he couldn't grow his physical storage. He couldn't do enough capacity planning. He couldn't get the sums right in order to provide a physical storage platform to back Spotify. And the one thing that he took away from this is that it's a large-scale platform and it can grow to meet his needs. He doesn't need to do capacity planning again because it's unlimited storage in S3. You, with your AWS account that you might sign up for today, you can access unlimited S3 storage. Now, another part of storage is backed onto instances, and it's called Elastic Block Store. So when you have an instance, a computer running, you have what we'd call a virtual disk drive, if you like, an Elastic Block Store. So this is a block storage device as opposed to an object storage device like S3. So this is where, when you launch an instance, the operating system is installed and it will boot from these drives. And you can add more or less of these drives to your instances. You can have 1 terabyte in size of an EBS volume, and of course you have multiple of those volumes. But it integrates with our snapshotting feature, so you can take a snapshot, an instant copy of a drive, and push that into S3 for storage, so you can recover it or clone drives. You can move EBS volumes between instances. So if an instance has a problem, you can just take the EBS volume and start a new instance from it. So this is the fundamental formatting that you can put across it to support a Windows OS or a Linux OS. Now I mentioned Glacier as well. So Glacier is built like S3 in terms of the same sort of durability levels, but it's designed such that we put items in very sort of long-term archive. The idea being is that you can do that very cheaply in Glacier because we don't expect you to retrieve objects very often. So you only start really paying when you go above a threshold of the amount of archives you're retrieving. And it takes about 3 to 5 hours to retrieve an archive from Glacier once it's in there. Now, one of the really neat things is that S3 is integrated to Glacier, and you can set policies on S3 that would say, these objects, maybe these log files, after 6 months I want them archived in Glacier, and after 5 years I want them deleted from Glacier. So there's an assumption that those objects won't want to be accessed, and if you do, it's probably under some audit or special condition. It's probably the only copy of those logs you've got, but you can place them in Glacier and effectively do what you traditionally do with tape, but do it online. Next along the list is databases. So databases is very common, and we take away, if you like, the muck of managing a database platform, providing relational database service, or the database as a service. So there's no need for you to install and manage databases on EC2 instances. You can, of course, if you're looking for a variant of database that we don't provide in RDS. We currently support Oracle, MySQL, and MS SQL Server. So they're pre-configured. You just choose how big your database you want. You choose when we can do patching of that instance. You choose whether you want it to be multi-availability zone, so that it will handle the failure for you, if you want read replicas, and so on. And then we'll stand you up that instance, give you an endpoint, and we'll manage everything from there all in for you. Take automated backup so you can go back to a point in time and recover data at any point in time. So it really takes away a load of the effort of managing a database server, and it's very cost effective. You can even use this within the free tier within AWS on a micro. So another popular example of somebody that uses RDS as a bedrock to their online facing services like forum threads, site content to support their games is Sega. So they have RDS in a multi-AZ deployment, so that means that there's a master in one availability zone, a slave in another, and that will handle the failover of any problems occur. And within that, we're handling live game metadata and user-generated content from a range of titles, And it takes away the pain of them managing the time-consuming administrative tasks normally associated with setting up a highly scalable, fault-tolerant relational database structure. Lets them get on with dealing with the production of great content and great games. Another database platform is DynamoDB. DynamoDB is a NoSQL data store. So this is solving a challenge of non-relational structures, very high scale, very high volume, where you're looking for consistent throughput performance regardless of scale. Traditionally, relational databases degrade when they become very, very large, difficult to maintain. You have to shard them, partition them. DynamoDB solves that by allowing you to just dial up the provision capacity or throughput you require per table. So if you have one very large table and you want and you're getting hit on that table very, very often, consider maybe that being moved into Dynamo, and we'll handle all the clustering, all the partitioning of the data, and you'll only pay for the capacity you want in terms of read writes per second against that table. It's all backed by SSD hardware, so it's super fast, it's secure, and it integrates with all the different services, and particularly Elastic MapReduce, which we'll come on to in a little while. Beyond networking, compute, and storage and databases, there are then middleware type services that AWS offer. So if you're looking to connect application components or decouple them, if you like, via a queuing system, you might be using Java messaging system, you might be backing those messages onto a database, so using the JMS against an Oracle database or what have you, to create a persistent, reliable queuing infrastructure. SQS, the simple queuing service, provides you with that at a regional service level. So just like S3, you can drop a message into queue, you can have an unlimited number of messages in those queues, and they're redundantly stored across multiple availability zones. So you can simply pop a message in and then pull it out when you're ready. So great for decoupling workloads and for handling some elastic, maybe batch processing. We also have a simple workflow where your workflows are more complex than maybe are practical to support over just simple SQS queues. So where you need to make decisions, where you need to handle metadata, where you need to handle rollback, auditing, and so on. SWF is a framework that enables you to coordinate tasks in some sort of sequence. And one of the customers that use this is NASA JPL. So this is Opportunity, who is still moving on Mars years after he was supposed to have failed. And his workflow through SWF is around taking imagery from the rover back through relay satellites to JPL and essentially taking left and right images, doing some warping actions on them, stereo matching, creating a 3D map and tiling things together to create a picture. Pictures which are presented to the operators and to the public on NASA websites. And they're images like this. So this is a tiled image of many different fragments that are pulled together using a simple workflow in AWS. And there we can see the tire tracks of where this rover has been. But that platform is still in use today. And the Curiosity rover that's currently doing experiments on Mars, again, all the bits coming back from Mars are passing through a simple workflow. And at the same time as JPL engineers received the first images of it landing on Mars, we did as public too, all published through AWS. And there's an image from the latest rover there, one of the first images tiled together. So one of the things that NASA JPL do is integrate EC2 resources with their on-premise resources using simple workflow. So they're able to coordinate between existing assets and cloud-based assets. So that's quite a useful tool where you already have compute resources you wish to use. Some other services quickly is cloud search. So Amazon Retail have the A9 search engine behind their websites. That same A9 engine has been wrapped into a service by AWS and it's called Cloud Search. So similar to handling NoSQL databases, when you have very large search engines like Solr and OpenSearch platforms, at scale you have to cluster them, you have to shard indexes, you have to maintain them, you have to work out the capacity planning to get consistent search times across your datasets. Cloud Search takes away that problem. It's an elastic backend, gives you a simple pair of endpoints, one for performing searches and one for pushing documents into. So if you have search across large data sets, Cloud Search is a great pay-as-you-go elastic service to take away the pain of managing a cluster on OpenSearch. CloudFront, I've mentioned, allows you to distribute content globally, so you can publish straight from S3, for example, streaming media, or download assets like images or CSS files or JavaScript files, and you can serve those things as close as possible to your end users so that you're getting the best possible experience for those users. And then we have Elastic MapReduce. So if any of you are using Hadoop, this is a managed Hadoop service. So again, it allows you to grow and shrink the number of EC2 resources, all handled by the Elastic MapReduce framework, to process very large data sets in parallel. Okay, so typically used in what we call big data scenarios, where you might be trying to do transactional log analysis across hundreds of web servers. Amazon Retail, for example, looking at what a customer has done, where they've clicked, and trying to make recommendations off the back of it. Looking at people like Etsy, for example, their recommendation is all Elastic MapReduce jobs, churning huge data sets, very fast, very cost effective, to provide more insight and more drive around their activities and applications. And then at the top level, deployment and administration, we have frameworks like Elastic Beanstalk that takes away all the management of underlying EC2 resources, of relational database platforms, of Elastic load balancers, and just lets you deploy an application, maybe direct from Visual Studio or direct from Eclipse, or Git push maybe for some Ruby or Python code. Enables you to deploy into a Beanstalk. We'll create all the resources in a model framework architecture behind the scenes, create RDSs and populate them. We'll manage versions of applications that you're deploying across the top by storing those in S3 and consolidate logs. So it's a framework that manages the underlying EC2 resources for you, so you can get started really quick straight from the dev bench. And this is a production ready system. We have customers that this is their production application platform. But you can access all the underlying resources yourself. So if you want to stand up a test site, you can really see how we configure auto-scaling, load balancers, relational database servers behind the scenes, because you can dip in and play with those in the console. And for those of us that maybe are of a more sys operations sort of side of life, that are looking for high degree of control, scriptability, CloudFormation is our templating framework that enables you to automate the creation of stacks, whether it be the creation of a single server or a cluster of servers. Everything you can do in AWS, you can do programmatically, if you like, via a CloudFormation template. And it's a simple text file. And ultimately, you can have applications which define what resources they need to run. And this definition, if you like, of the virtual data center can be shared, can be diffed, can be compared, and so on. So you can drive these stacks. And the NASA JPL example I gave you, when they have NASA TV, when the rover first landed, they were launching stacks of 110 servers in order to scale out their video processing demand as people were hitting on their websites looking for the first images. And we have other things. We have identity and access management. So we've got full role-based access controls throughout the platform. We provide you with SDKs in all your common languages, up to the latest Node.js SDKs that we provide. So you can integrate these services, create these services from your favorite programming languages, scripting, direct at the command line, and so on. And there are others, so many more. And some of those, just so you know, simple emailing service. If you're looking to send lots of emails, we have that platform. We have a pub/sub framework called the Simple Notification Framework. Elasticache is a managed memcached service. So if you do caching in front of databases for performance, you can do that again on a pay-as-you-go Elastic basis. We have an integrated monitoring framework called CloudWatch. And then there are services like Storage Gateway that enable you to download a virtual machine, install it in your physical premises, and automatically take backups of maybe local disk volumes and push them into S3. So you've got a secure backup and archive process going on. But there are also 3 new services. Very new is Redshift. So this is in a private preview at the moment, in that this is data warehousing as a service. So we looked at one of the biggest expenses in a number of our customers, and it was and a core to those businesses was the handling of a data warehouse to drive business intelligence. And Redshift was trying to do data warehousing the AWS way. So the idea being we could do it 1/10 the cost of traditional data warehouses for petabytes of data. And this sort of test factor around Amazon.com's retail warehouse was traditionally had a 32 node cluster, several $1 million a year of maintenance and licensing costs to run the data warehouse behind Amazon Retail. and they tested 2 billion rows of that with the 6 most complex queries, and they did it for $3.65 an hour. So that's the kind of differential that we try to offer in our services in terms of cost, in terms of ease of access. And of course, like all of our services, Redshift, when it's public, will be just a pay-as-you-go, turn it on, turn it off service. Another service which our customers have been asking for is the ability to shift large amounts of data around within the cloud and indeed on premise in order to be able to do things like big Hadoop jobs, big Elastic MapReduce jobs. So where you've got data in S3 buckets, where you've got lots of log files on application servers, where you've got relational databases, pull these things together via a pipeline, so a scheduled pipeline, and consolidate that data and place it somewhere where you can do something with it. So data pipeline is an underlying framework that's available for you to do that today within AWS. And then lastly, one we released yesterday is something called the Amazon Elastic Transcoder. So if you're in the business of producing movie files in different formats to support different types of endpoints, you'll be familiar with running encoding software, having to scale that up to meet demand at any particular time, and so on. Now, Elastic Transcoder simply lets you choose some assets in a source bucket in S3 and to choose where you're going to deposit that resource in an output bucket in S3, and then choose some presets. So whether it be encode a video file at 720p HD, whether encode it for a Kindle Fire, whether look at presets for iPhones, and so on and so forth. And you can run multiple of these processing pipelines in parallel so that you can churn through the video transcoding that you might need to do, and you only pay for the number of minutes transcoded. So a unique model. Okay, so really to close up today's webinar, we'll start looking at sort of 2 common questions that are asked then. So the number 1 enterprise question will be, is my stuff secure if I put it in AWS? Where is my stuff? How can I be confident around how it's being handled by Amazon? Well, security is our number 1 priority, and our facilities have a number of standard badges and certifications that are regularly audited against them. So, physical security, platform security, the people and procedures that we deal with, and the network security are covered by SOC 2 audit, which is a standard, if you like, SAS 70 type audit. So a standard list of procedures and controls that we're audited against. We also have SOC 1. We're also ISO 27001, and these again are regular audit. Also go to our security center and download white papers on how we operate. So we try to provide the most secure basis of infrastructure for you to build your systems upon. And as such, it's a shared responsibility model, because we provide these certifications at the infrastructure. What you build on the infrastructure is down to you. So the applications, the operating systems, the host-based firewalls, what have you, how you use our tools like security groups to secure your instances is down to you. So a shared responsibility model. And we provide you with help and guidance on that in terms of online, and we also provide tools for our support infrastructure called Trusted Advisor. But if you look at a couple of quotes here, my favourite on the left of Gus Hunt, CTO of the CIA, talks about the scale at which Amazon's at, the number of customers that are in there, make it a very difficult attack point to people in the outside world. It's polymorphic. There's lots of different things behind the IP ranges. It's very difficult to ascertain a single attack point in order to focus upon it. So ultimately, that drives a higher security stance or posture for everyone in the cloud. And if you think about it, if I've got this, Amazon Web Services has the Chief Information Security Officer as Shell or Samsung or any other of the very large enterprises requiring that AWS do X, Y, and Z, everyone benefits when we do that, because everyone gets the same thing through that platform. Second most common question really then is, how does the cloud work with existing on-premise resources or investments, and how do I integrate what I have? I don't want to create an island in the cloud where I have resources that I want to use internally. And I then get asked the question, well, what's a hybrid cloud in that case? Well, you think about what a hybrid cloud is, or how you integrate resources, and we like to think of it as the elastic data center. So you have some assets in your corporate data center today that you're using. Maybe these are running customer-facing systems, internal operational systems, dev test environments, and so on. And you start wrapping, if you like, the resources that you might put in the cloud out there in your own security, your own controls, extending things like your address spaces using VPC, maybe direct connecting between these environments with a direct connect and putting VPNs across the top. And then being able to extend your data center with resources, whether it be to stand up an SAP environment to test the latest changes you're making to it, whether it be to run a high performance cluster to do some deep data analysis, whether it be to do dev test environments that you spin up on a Monday morning and turn off on a Monday night when everyone goes home. And the trick is then to bring those resources back and integrate them together. So being able to burst into the cloud, being able to stand up new projects that are in some way using mixed data resources, maybe shipping data into AWS, perform a very large Elastic MapReduce job, and then pulling data back out of S3 back into internal databases for analysis. So the idea that the Elastic Data Center, we provide you with the controls to enable you to wrap this stuff, and we provide you with tools to support those sorts of architectures. So I've mentioned private network connections. We've got tools that enable you to migrate workloads or data between the cloud and on-premise. You can federate your maybe Active Directory with our IAM, role-based access. And there's a whole host of tools that we provide you in the ecosystem to enable you to do that as well. So do look on the website to get more information. So in summary, to close off today's webinar, why are customers adopting the cloud? Variable expense, removing CapEx and moving onto OpEx. They can achieve economies of scale. There are hundreds of thousands of customers on the platform, can't achieve those sorts of economies of scale on their own. Everyone benefits from the community effect. Elastic capacity, you only pay for what you need, and when you don't need it, you throw it away. And because of that, they get speed and agility. They're able to innovate faster. And they're no longer focusing on racking and stacking servers. They're focusing on building great apps and innovating on behalf of their customers. And if they need to, you can go global in minutes because it's a global platform footprint. So thank you very much for listening. Hopefully you found that of value. As always, you can find out more at aws.amazon.com.